Okay, so exciting stuff. We are solving equations now. So solving equations means we want to isolate for a variable. We want to figure out what x is equal to, or m, or whatever the letter happens to be. So when we solve an equation, we are trying to isolate a variable. And in order to do this, we must get rid of everything else. We need to get the variable by itself. This is why we use inverse operations to eliminate anything on the same side we're trying to isolate, and inverse means the opposite operation. So if we have addition, subtraction is the opposite. If we have multiplication, division, if we are squaring something, then the square root would be the opposite. And if we're cubing something, then the cube root is something that we would do. Now, I don't know if you've seen that before, but if you check your calculator, you'll see it. It should be one of the buttons on there, the cube root. Okay, so just as a reminder, an equation is something that has an equal sign. So an expression would be something like x squared plus 5x minus 3. That's an expression. But as soon as I make it equal to something, that makes it an equation. Okay. Get rid of that. So whatever we do on one side, we have to do to the other. The exact same operation must be performed on the other side. Okay, otherwise the equation won't be equal anymore, and it's not an equation then. So what we're looking for is BEDMAS backwards to isolate a variable. Okay, BEDMAS in reverse. So when we look at BEDMAS, I'm looking for normally if we're looking at BEDMAS going forwards, we'd be looking for brackets, exponents, division, multiplication, addition, or subtraction, but now we're looking backwards. So first thing I'm looking for is addition or subtraction. So let's look at number 1 here. I'm trying to solve for C, isolate C. I think about what's happening to C. I'm subtracting 5. So the opposite of subtracting 5 from C is to add 5. But remember, whatever you do to one side, you have to do to the other. So if I add 5 here to get rid of this negative 5, I need to add 5 to the other side as well. Now, this isn't a hard question. I know that 8 minus 5 is 3. But what we're doing is using these operations to figure out how we would answer harder questions. So negative 5 plus 5, that's 0. They're gone. And the reason I'm doing that is because I want C by itself. And on the left side now, all I have is C. And on the right side, 3 plus 5 is 8. So C is equal to 8, which we knew, right? 8 minus 5 is 3. Let's look at the next one. Okay, what's happening to A? There's a 2 around it. There's a 2 there. I want to get rid of that. So what's the 2 doing to A? If there's no sign in between 2 and A, there's nothing here, that means it's multiplication. So the opposite of multiplying by 2 is dividing by 2. So I'm going to divide that by 2. But whatever I do to one side, I have to do to the other. So these 2's will cancel out, meaning 2 divided by 2 is 1. So I'm left with 1A on that side. And negative 7 divided by 2 is negative 3.5, or we can just leave it as a fraction, negative 7 over 2. Okay, so what this means, if we go back to the original question, 2 times negative 7 over 2 was equal to negative 7. Okay, now, remember what we said before, BEDMAS in reverse. So, if I'm looking at BEDMAS in reverse, the first thing I look for is addition or subtraction. So in here, if I'm looking at what's around E, I'm multiplying by negative 4, and I'm adding 6. So there's my addition or subtraction. So that's what I'm going to get rid of first. Then I would look for division or multiplication. So I would get rid of the negative 4 after, because it's multiplying by E. So first thing I'm going to do is subtract 6. Again, do the same thing to both sides. So positive 6 and negative 6 is 0. That's eliminated. I only have negative 4e on the left side. 16 minus 6 is 10. So I look at what's around e. I'm multiplying by negative 4. I do the opposite of that, which is to divide by negative 4. Okay, and this means division, right? I'm not subtracting 4. This is dividing. That line means dividing. So the negative 4 and negative 4 will cancel out. I'm left with e and negative 10 over 4. It doesn't matter where that negative is, on the bottom, top, in the middle, doesn't matter. But we want to simplify that to negative 5 over 2. Okay, so that's solving those equations. Let's move on. Got quite a bit to do today. What is happening to h? Now, the 5 that's here, it's in front, so some people get confused saying, what's that doing? I'm subtracting 9, but we're thinking about what's happening to h. So this is a positive 5. And if it's a positive 5, it's just hanging out over here. It's adding. It's not next to the h, it's not multiplying, so it's adding to it. That negative 9 is multiplying. So we're going to do the opposite of those things. Remember BEDMAS in reverse. So the first thing I have to do is get rid of that 5. And the opposite of this positive 5 is minus 5. But same thing to the other side. So that gets rid of that. Those will be 0. So on the left side, the equal sign is still there. 23 minus 5 is 18. On the right side, I have negative 9h. And to get rid of the negative 9, since it's multiplication, I would divide by negative 9. Negative 9s cancel out, and by cancel out I mean becomes 1, so 1h is equal to negative 2. Okay, next one. What's happening to f? I'm dividing by 2, and I'm subtracting 7. So BEDMAS in reverse, I look for addition or subtraction. I'm subtracting, so the opposite of that is to add 7. Those two go to 0. Gone now. So on the left side, I have f over 2 is equal to 18. So something divided by 2 is 18. Right? Or f is divided by 2. So the opposite of that is to multiply by 2. So I'm going to multiply both sides by 2. And when I do that, 2 divided by 2. Okay, so imagine this line has gone all the way across. Excuse me, 2 divided by 2 is 1. So I have f is equal to 36. Right, so then we figured out that 36 divided by 2 minus 7 is 11. That's what we would do. If we put it back up here, 36 divided by 2 minus 7 is equal to 11. All right, so now we want to figure out what value of k can I put in there so that if I do all these other operations around, the answer will be -8. So I look at k and I think, what's happening to it? Bed mass in reverse. So I look for addition or subtraction, and I see that there's addition there. I look for multiplication or division, and I see there's multiplication here. There's multiplication, there's division. So I got to figure out what I'm going to do first. Now, if we look at bed mass in reverse, brackets are last. So I can't touch anything in here. The bracket is off limits because it's the last thing. So I need to get rid of the 3, I need to get rid of the 2. What's the 3 doing? What's the 2 doing? So the 3 is dividing all of the top, the numerator. The 2 is multiplying. You can do it in one step, but I'm going to do it in 2 right now. So I'm going to get rid of the 3 first. Since I'm dividing by this 3, what we'll do is multiply by 3 in order to get rid of that. So I'm going to multiply both sides by 3. That cancels out. Equal sign is still here. So now on the left side, 3 times -8 is -24. And I have 2 times 3k plus 3. Now you could multiply the 2 in and solve from there. But we could also get rid of it now. Since the 2 is multiplying in, the opposite of multiplying by 2 is dividing by 2. So these 2's will cancel out because 2 divided by 2 is 1. And I have -12 is equal to 3k plus 3. And now it's similar to what we had before. I'm going to do bed mass in reverse because there's no more brackets. So this was what was in the brackets. I got rid of the division. I got rid of the multiplication. And now we're dealing with the brackets. And when you go in the brackets, you start over again, bed mass in reverse. I look for addition or subtraction. The opposite of adding 3, subtracting 3. And -15 is equal to 3k. The opposite of multiplying by 3 is to divide by 3. It cancels out. K would be equal to -5. Okay. Now, let's look at number 7. What's happening to M? Bed mass in reverse. I'm adding 3, dividing by 3, multiplying by 7. So these two things are that division or multiplication. It doesn't matter the order that I get rid of these ones. But since I'm doing bed mass in reverse, I need to get rid of this first. So I'm going to subtract 3 since I'm adding 3. So what's left? The 3 and the -3 go to 0. So on the left side, I have 7m over 3. -4 minus 3 is -7. Now, I want to get rid of the 3. I want to get rid of the 7. What's the 3 doing? I'm dividing by 3. So the opposite of that is to multiply by 3. Now there is a way to get rid of this 7 and 3 in one step. I'll cover that a little later. But for now, let's do it in 2 steps. So 3 divided by 3. Imagine this line goes all the way across because that's what's happening. It's 3 times this 3 times 7 divided by 3. But what we can do is divide out those 3's. It's the whole reason for doing this is to get m by itself. So now I have 7m only and negative 21. Now to get rid of that 7, I'm going to do the opposite operation, which is divide by 7. So m is equal to negative 3. Okay, on to the next one. What's happening to r? Well, in this case, r is on the bottom. R is in our denominator. 6 is in the numerator, so there's going to be a little bit of extra work here. But first, let's get rid of this 2. We know how to do that. Subtract 2, subtract 2, right? The opposite of adding 2. So now on the left side, I have 6 over r is equal to 6. Okay. This canceled out to, or added to 0 is a 0 sum. So I have 6 over r is equal to 6. Again, there are different ways to do this. You can probably tell right now that this going r is equal to 1 because 6 divided by something is equal to 6. It must be 1. There are different ways to do this. I'm going to show you a bit of a longer way, and then later on I'll show you a shorter way. So since the thing that I want, the variable, is in the denominator, I can't solve for it when it's down there. It needs to be in the numerator. So I'm going to multiply by that variable. Because if I multiply both sides by that variable, it cancels out here. But now it's in the numerator on the other side, because I multiply both sides by that variable. Still not by itself, but at least it's in the numerator now. So now if I divide by 6, because that's what the 6 is doing to r, r is by itself, and it's equal to 1. Again, I'm going to show you a different method in the next one. All right. So we could do what we just did. We can multiply both sides by v to get v out of the denominator. In fact, why don't I just do that, and then I'll show you the second method. So, method 1. Let's multiply both sides by v. So the v's will cancel out. And I have 4 is equal to 7v over 8. So now v is not in the denominator, it's in the numerator. And I want to get rid of this 7 and this 8. So I would multiply by 8 and divide by 7. I could do that in 2 steps, but let's do it in 1. If I multiply by 8, I'd be multiplying both sides by 8. And then in the next step, I'd be dividing by 7. So let's divide by 7 at the same time. So I'm multiplying by the reciprocal of this fraction. I flipped it. 7 over 8 times 8 over 7. So now this 8 and that 8 will cancel out. 7 and 7 will cancel out. So what you're left with is v is equal to, and then 8 times 4 divided by 7. So 32 over 7. Now there's another way. Okay, now this only works because I have 2 fractions that are equal to each other. It's a proportion. What I can do is flip both ratios, or flip both fractions. As long as I take the reciprocal of both, it's fine. Not just one or the other. So I'll get v over 4 is equal to 8 over 7. So now to get rid of the 4, because I want v by itself, I would just multiply both sides by 4. And if you look over to the other side, that is the same as that. Okay, so the 4's will cancel out. V is equal to 32 over 7. Now both methods have their place. Just depends on how complicated the equation is and how you're manipulating things, especially later on in your more complicated courses. So either way, doesn't matter as long as you get the right answer. All right. Now, remember bandmass in reverse, so I'm subtracting 4. For number 10, I'm going to add 4 to both sides. And on the left side, I'll have t squared is equal to 25. And I'm doing the opposite operation. So if t squared is equal to 25, that means something squared is 25. So you can probably figure out it's 5. 5 squared is 25. But what you would do is take the square root of both sides. Okay, if it's not something that you can figure out in your head, you're going to take the square root of both sides. Then we know that t is equal to 5. Okay. Actually, it's a little more complicated, slightly more complicated than that. Let me do the next one and I'll come back to this. I don't want to confuse you too much. Okay, so number 11. I think that's the last one, yeah. And look at what's happening. I'm subtracting 3 because it's a negative, so I want to add 3. So these become 0. I'm left with just n cubed on the right side and negative 27. So the opposite of cubing something is the cubed root. So something times itself 3 times is negative 27. That's negative 3. Okay. Now, I'm going to come back to number 10 for a second. The square root of 25 is 5. 5 times 5 is 25, but there's another possibility. When I take the square root of something, it's possible that it's positive 5, but it's also possible, that it's negative 5, because negative 5 times negative 5 is positive 25. So what we say is that t is equal to positive and negative 5. It's equal to both. It's both possibilities. 5 times 5 is 25, but also negative 5 times negative 5 is 25. So t could be either positive 5 or negative 5, and you'd still get the right answer. So if I put positive 5 in here, 5 squared is 25, minus 4 is 21. If I put negative 5 in there, remember it has to be in brackets, negative 5 squared is positive 25, minus 4 is 21. Still both works. So when you take the square root, you yourself take the square root of something, you don't know if it's the positive answer or the negative answer. So you have to say both. It's both positive and negative. Okay. So that's the end of that question, or these questions. The next section is more solving, but just different ways of solving.